Hello guys, welcome back to another video. Today we're going to be looking at a very interesting problem, as you can see here. Y equals xy all to the power of xy, and we're trying to find the first derivative. So let's get started. I'm going to move this to the side, and let's write this. So immediately, we see that there's an x in the base and an x in the exponent. Usually we can't apply our standard derivative rules when doing this, so we have to use something like implicit differentiation or logarithmic differentiation, and it's not sometimes not too complicated, or it can get more messy. We'll find out. Rewriting this equation, y equals xy all to the power of xy. If we take the natural log on both sides, something interesting happens. The natural log of y is equal to xy natural log of xy. So that's a quite interesting fact because of the nature of the natural logarithm function. Natural log of 2 to the x, for example, is equal to x ln 2. We can bring this exponent down as a coefficient of the natural log if and only if that is the exponent of the entire term. There can't be multiple terms, or it has to be strictly under these conditions. So you can see we can move this coefficient down like that. That's how the natural log works. So one thing we can do right here is we can immediately just derive this function. If we take the derivative on the left-hand side, it's like applying d dx with respect to x on both sides, and then solving for dy dx, which is what our essential question is. Y prime equals dy dx. We're trying to find that. That's the essential question. So the derivative of ln of y with respect to x is actually 1 over y times y prime, because d dx of ln of u, where u is a function of x, is equal to 1 over u times u prime due to chain rule. And if you guys want to see a different video on that, feel free to leave a comment and I'll see if I can do something. So immediately we have this on the left-hand side, and then on the right-hand side, let's take the derivative of this. It looks a little bit nasty, but I think we can do it. The derivative, using our product rule, f prime g plus g prime f, where this is f and this is g. What do we have on the right-hand side? We get derivative of xy. That would just be xy prime plus y. And then we have, because we have x as it remains, multiplied by the derivative of y, plus y times derivative of x, which is just 1. And then we have ln of xy plus then xy, and then what's the derivative of ln of xy? That's just 1 over xy times the derivative of xy. What's the derivative of xy? Let's see. And to not confuse you guys, we can clarify this a little bit. Because we just went from this step, we're trying to find, we first did f prime g, which is this part right here, and now we're doing g prime f, which is this. So we have to leave f as it normally is. This is f. Then we take the derivative of g. The derivative of g was 1 over xy, and then times the derivative of xy. But you will notice some funny canceling, which we'll get to in a minute, and then we simplify. So in all, we have 1 over y times y prime equals xy prime plus y ln of xy plus, this cancels, xy prime. What is xy prime? We just found it. It's right here. Xy prime plus y ln of xy. Oh, we don't even need that ln. We don't need that. That's not part of it. So that's what we have so far. Now all we have to do is just solve for y prime, because that's the essential question. Now, you'll notice since we have this here and this here, we can just factor out an xy prime plus y. Now let's do that. We have y prime over y is equal to xy prime plus y, parentheses, ln of xy plus 1. Let's rearrange a few things. Then we get y, let's see the best way we can do this. We're trying to solve for y prime, of course, because that's our derivative. So simply dividing by this will not get us anywhere, because we want to solve for this instead. A possible another way was to just expand it and then rearrange the terms to solve for y prime. So I think let's go for that. Instead of this approach, what we're going to do is we're going to do y. We're going to keep our y prime over y over here and expand this out so we can get y, so we can eventually get y prime. By multiplying these together, we have xy prime ln xy plus y ln of xy plus xy prime plus y. And then we rearrange a few things. We have y prime over y minus xy prime ln of xy minus xy prime is equal to, then we just have this and this, y ln of xy plus y. And now we can just factor out a y prime. We have a y prime times 1 over y minus x ln of xy minus x, which equals y ln xy plus y. And now to solve for y prime, we have y prime is equal to y ln xy plus y all over 1 over y minus x ln of xy minus x, where y is equal to xy to all to the power of xy. And you can rewrite that however you want, but just for these purposes, we'll leave it in this form. I hope you enjoyed this video, and let me know if you have any questions. Thank you guys. See ya.